Arsenic,
the poison of kings,
Thallium,
the poisonous poison.
both entered history through medicine, industry and murder. Today we are diving into their chemistry, their compounds and the strange way we humans have used them. I'll even be making the infamous pigment once blamed for killing Napoleon. Bonaparte.
Let's get straight to it.
Beautiful chemistry with a dark history.
This molecule you've just seen, tetra-arsenic trioxide. It is a molecule specifically associated with realgar. Realgar is arsenic and sulfur, 4 arsenic and 4 sulfur. It is a bright red mineral. When it is exposed to light, it chemically degrades, oxidizes to a yellow-orange powder, which includes tetra-arsenic trioxide. Ancient alchemists called this process the shedding of the serpent's skin, because the red flesh of the stone turned into a yellow husk. It is also the bane of museum curators. Arsenic tetroxide is not the dominant oxide. Arsenic likes to be in the +3 or the +5. This is a less stable oxide in the +2.
Hello there. Welcome to my series about the poison. There are very many poisons. All things are poison, and nothing is without poison. Only the dose permits something not to be poison.
In the late 1800s, the stable biocidal paint, copper acetoarsenide, known as Paris green, was applied to the hull of ships. Developed in Germany by Wilhelm Sattler and Friedrich Russ at the Wilhelm Dye White Lead Company, Schweinfurt, Bavaria. It was an improvement on Scheele's green, discovered a few decades earlier by Carl Wilhelm Scheele. Toxicity of arsenic saw these Victorian green pigments have some uses beyond just paint. It was a favourite of Claude Monet. His Water Lily series consists of 250 oil paintings. He used Paris green in the earlier ones, and he used Paris green in his famous depiction of the Houses of Parliament in Westminster.
Paris and Scheele's green were used in wallpaper, and this is how Napoleon is said to have died. A fungus called Scopulariopsis brevicolis has enzymes that eat this pigment and poop out deadly trimethylarsine gas, which accumulated in Napoleon's system and contributed to his death. This compound is also found in deer truffles.
It was used to kill rats
Until they realized they were contaminating the water supply. Arsenic poisons were used to kill rats in the sewers of Paris.
and as this anti-fouling ship paint, preventing barnacles attaching to the steel and wood of these late 1800s and early 1900s ships, essentially chemical warfare against the ocean. The addition of the acetate group created a more complex crystal structure. It was more insoluble than Scheele's green, which was known to fade. arsenic, concentrated sulfuric acid is added. This is capable of oxidizing the arsenic to arsenic trioxide. If you use fuming sulfuric acid and selenium dioxide as a catalyst, you can get further oxidation to arsenic acid. As4O6 molecular units form in these hot acidic conditions. While it's the stoichiometric equivalent of arsenic trioxide, it can technically and perhaps more accurately be called tetraarsenic hexoxide. I mean, if you really want to be fancy, call it by its IUPAC name. At these temperatures, it exists as a vapor. The white fog is the vapor condensing in the cooler air above.
Yes, well, one must be rigorously scientific about these things.
Below 193 degrees Celsius, it condenses, crystallizes as cubic arsenalite, discrete cage molecules. This is the kinetically favored form of arsenic trioxide. I think these cubic crystals are beautiful. They're the nicest crystals I've ever seen. With our 4:3 ratio of copper acetate and arsenic trioxide in solution, the arsenic and copper ions are just sitting there. We need to manage the acidity. Potassium carbonate is the catalyst that, through neutralization of acetic acid, acts as a buffer to allow the complexation of the arsenic and the copper ions. Here is the quite long equation. detect the hidden poison, use the marsh test. I place the suspect sample into this flask containing zinc and sulfuric acid. If arsenic is present, it reacts with the nascent hydrogen to form arsenic gas. I ignite the gas escaping the tube. It burns with a characteristic livid blue flame. By holding a cold porcelain bowl over the flame, the gas decomposes. Doesn't have enough time to react with oxygen. We get an arsenic mirror. Arsenic gas has been studied as a chemical warfare agent. Its odor threshold is higher than its toxic limit. It destroys red blood cells, leading to kidney failure, jaundice, and often death.
If you add some chromium ions, some chromium 3 and chromium 6 to our copper arsenate, you get chromated copper arsenate, which is a phased out wood treatment. The reason it's phased out is because it can leach and it is soluble, so it leaches out into the environment. Small bits of copper, arsenic and chromium, and some hexavalent chromium, yes. Although the cellulose and the lignin act as reducing agents that convert this into trivalent chromium.
Arsenic trioxide, while toxic, it is an FDA-approved acute promyelocytic leukemia drug that forces cancer cells to mature and die. Another arsenic derivative, marlazaprol, while also acutely toxic, is used to treat African sleeping sickness, which itself is fatal without treatment. The ones that are wise to avoid are almost exclusively the inorganic compounds. These usually feature an arsenic atom bonded to either an oxygen, a chlorine, or a sulfur. Organic arsenic compounds are far less harmful because the body cannot metabolize arsenic into a toxin when it is bonded to a carbon. This old marsh test would have tested positive if the cadaver had eaten seafood containing any of these: arsenocholine, arsenosugars, arsenobetaine. The old tests were qualitative, visible tests, whereas modern inductively coupled plasma mass spectrometry can detect one part in a trillion, and also tell you the species.
Wow.
So it could be possible that people were sent to the gallows for poisoning somebody with arsenic when all that happened is they had a heart attack, died of natural causes. Well done for making it this far. Don't go anywhere. Part 2.
Fairy dust. Fugazi.
Tawazi, Wazi.
It is no matter. It's not on the chart. It's not fucking real. It's not on the elemental chart. It's not fucking real.
Thallium.
tasteless poison. Agatha Christie's The Pale Horse described the symptoms of thallium poisoning so well that doctors use this as a reference. With just 1 gram of thallium sulfate or another soluble thallium salt, ice cream sprinkles of mortal delight. Thallium sulfate is tasteless and highly soluble. The answer to the question, why is thallium so toxic, is hidden inside this orbital diagram. Stay tuned to find out just how this beast of an atom is able to indiscriminately shut down multicellular life. With just 1 gram of thallium sulfate, ice cream sprinkles of mortal demise.
In its +3 state, it resembles that of others in group 13. Thallium 1 ion is what sets it apart from the rest of the group as a pseudo-alkali.
We're going to be making thallium iodide. So let's talk about iodine. Ancient Greek for violet, after the intense color of its vapor.
What can I say? A halogen worthy of this short tangent, deserving of its own video, but with it being element 53, it didn't feature in my Architecture of the Elements series. Just like stellar nucleosynthesis, the series peaked with iron. Incidentally, this color comes from the same physics that give conjugated molecules their color. It's the shared delocalized electrons. They absorb a certain frequency. The absence of this frequency transmits back as color. Of the stable halogens, it is the largest. It is a solid. It is a non-metal with 7 valence electrons. It seeks company. If there's no one else around to bond with, it will have already paired with another iodine, forming the standard diatomic iodine. This way they fulfill each other's octets. Monoatomic iodine is a free radical. These I2 molecules can be divided, but you'll never see a jar of monoatomic iodine. unless this jar is pressure resistant and is over 1000 degrees Celsius. At this temperature, these bonds have started to break. This is an equilibrium reaction driven by heat, or more accurately, driven by energy that exceeds bond dissociation. Driven by energy exceeding that of its bond dissociation. With energy enough to dissociate the bond.
The name is bond. Weak intermolecular bond.
Bond. Double bond.
Shaken, not stirred.
Welcome to Wheel of Interest, the game show where correct answers to questions give you a chance to actually pay off the fixed interest rates on your impossible debts. So, what do we... 124 neutrons. Wow, that's a beast. 81 protons. 81 electrons. 3 contestants. Welcome to the Wheel of Interest. Question 1. Which noble gas would we build on to make this? Contestant number 1. And argon? No, it's not argon. Contestant number 2. Xenon. Correct. Xenon. Great, that's the first 54 electrons out the way. Now we can have these extra 4F and 5D blocks. Look at them, completely full. Finally, we have our valence electrons. These are the ones that participate in chemistry. We have a pair in 6s. That's one spin up and one spin down. But what's happening in 6p? We just have one electron there. Oh, I would feel sorry for him. All alone there. With this being such a huge, heavy atom, there will be a large electrostatic attraction from the nucleus. They won't have the energy to participate in much. We can see that thallium will have an easier time losing one electron than losing all 3. Thallium-1 salts are the more toxic ones. Now let's compare thallium-1 ions with other ions on the periodic table. We can see its radius is very similar to that of potassium. Our cells use potassium. We have a whole system that uses potassium. Potassium ions, being ions, have a charge. Cell membranes on all living things transport potassium ions in and out of the cell via ion channels. Otherwise they would not be able to get past the fatty membrane. These ion channels also serve as a barrier keeping out unwanted molecules out. Thallium is cunning and nonchalant, mimicking potassium, and is about to walk straight past the bouncer. That's why thallium-1 is so toxic.
Pseudo-alkali. It has 3 electrons in its outer shell, and due to the inert pair effect, 2 of them are bound too tightly to the nucleus to react. React this with potassium iodide. Thallium is a chemical chameleon. While it sits with the metals like gallium and indium, its chemistry, especially in the +1 oxidation state, closely mimics alkali metals like potassium and sodium. The ionic radius, because it looks like potassium to our cells, the body mistakenly absorbs it,
and this disrupts cellular processes. Your nails and your hair fall out, and your hands and your feet start to hurt. Thallium iodide alone can be used to produce green-colored metal halide lamps. At 175 degrees Celsius, the yellow orthorhombic form transforms into a red cubic form. This phase transition is accompanied by about 2 orders of magnitude jump in electrical conductivity, 110 to the power of 2 increase. In 2017, a mineral new to science called Natalia malachite was found in a high-temperature volcanic vent in Russia. I believe this was of some significance to the field.
You have a rock collection? It's a mineral collection.
You're looking at a rock at 2:24 in the morning.
This is not a rock. This is a mineral for like the 10th time.
Thallium bromide has optical properties for X-ray detection in scintillators. When mixed with thallium iodide, it is used as a lens for infrared spectroscopy, as it is capable of transmitting long wavelengths.